Dear student, let us see in friction one more very important situation that comes into picture when one block is placed on the surface of another rough surface, another rough block, and the lower block is moved. Then what should be maximum force applied on the lower block so that the two blocks move together? So let us see that situation, how to find out the maximum force at which the two blocks move together. The lower block is placed on the smooth surface. So let us see that situation, how to find out the maximum force. Now we'll take, let us take the smaller block M and a bigger block M is placed on the table. This is the situation. M, the table is smooth, so this is 0, and a force F is applied on the lower block, and the question is what should be F max, and there is coefficient friction between the upper block and the lower block. Now what is question, that what should be this maximum force F so that these two blocks move together or the upper block does not slide on the lower block. So question is what should be F max so that M and M moves together or M does not slide on lower block M. This is the question, what should be maximum force. So when we apply maximum force, then this will be accelerated in rightward direction. Let us say the acceleration is A0. Now A0 is the common acceleration of both these two blocks. Now when we draw the free body diagram of the two blocks, let us take the smaller M. Now this is accelerated in rightward direction with A0, maximum acceleration. Now normal contact force will be acting, that is N1, and its weight is acting in downward direction. Let us take, this is mg. Now we will see this is accelerated in rightward direction, so the maximum value of static friction will be acting in forward direction on smaller end. Now this is Fs max, or I can say this is limiting friction also, this is limiting friction also, and this will be equal to mu s time mg. Is it? Now I want to find out what should be this maximum acceleration produced by this limiting friction. Now we will see the net force acting, I can say F net on smaller block is nothing but it is Fs max, or I can say this is equal to mu s mg, and this should be equal to Newton's second law. As per Newton's second law, mass into acceleration A0. So I can say the maximum acceleration produced by the limiting friction is mu s into g. Is it? This is the maximum acceleration at which can be given to the upper block due to by the limiting friction. Now when you draw the free body diagram of the lower block, or I can say the lower block, if I draw the free body diagram, now since at this place friction is 0, coefficient friction is 0, so I can say there is no frictional force acting, mu s is 0, Fs is 0, the force is acting in rightward direction, that I can say F max, and on this the coefficient of friction between these two surfaces, this will act in leftward direction, Fs max. Is it? Now obviously N1 is acting on the upper block, so the reaction force N1 will be in downward direction, and here its weight will be acting in downward direction mg, and I can say the N2 will be acting in upward direction, the contact force between the lower block and lower. Now I am not interested in these vertical forces. Why? Because we know that this is accelerated in horizontal direction with A0. So I can say the net force acting in horizontal direction is F max minus Fs max, and that is equal to mass into acceleration. I can write the maximum force at which these two blocks move together is Fs max plus ma0. Now I can write mu s mg plus mu s mg. I can say it is m plus m mu s g. Is it? This is the maximum force acting at which the two blocks will move together. Is it clear? This is the maximum force, and the maximum acceleration is nothing but mu s g. Now let us take some data and let us see what happens if I take, let us say in question 1, if I take some numerical data, question 1, if I take some numerical data, let us take mu s is 0.1, right? Small m is, let us take 2 kg. Let us take the bigger m is 4 kg. And let us take g equals to 10 meter per second square. Now the question is, what should be maximum force F applied so that these two blocks will move together? Now I can say the maximum force is nothing for, if smaller m does not slide over the lower block, that I can write 2 plus 4 into mu s is 0.1 into g is 10. I can do 6 Newton. This is 6 Newton. F max. Is it? The lower there is the lower surface is small. Now if I apply, suppose in question 2, if applied force F is 12 Newton, which is greater than F max, then which is 6 Newton, then what is AM and what is acceleration of the lower block? This is the question. Right. Now when we apply 12 Newton, obviously what will happen? 12 Newton is more than the maximum force at which the two blocks move together. Now when we apply 12 Newton on the lower block, we'll observe that the lower block is accelerated more and the upper block is accelerated less. Now the upper block acceleration is fixed. Its maximum acceleration is mu s into g, and that is 0.1 into 10 or 1 meter per second square. But the lower block will have what acceleration? I can write the lower block will have acceleration, that is 12 minus the force acting is minus mu s is 0.1 and 2, this value is 2, mu s 2 into 10 divided by the lower block is having 4, so I can write 4. This comes as 10 by 4 to 10 by 4 and 2.5 meter per second square. This will be the acceleration of the. Now obviously you will observe the lower block is having more acceleration than the upper block. Right. Now let us take, based on this, one more example we'll take. If I say the question number 3 with data, if I take question number 3, suppose I take the lower block is of length 10 meter. Let us take, this is upper block M, this is M, force F is applied, this mu is 0, mu is here 0.1. Now question is, if we apply, and this force F applied is 12 Newton, right? Then we have seen the acceleration of the bigger block is 2.5 meter per second square, and the upper block will have fixed maximum acceleration, that is mu s g, that is equal to 0.1 into 10 or 1 meter per second square. Now I will say the relative acceleration is now lower block minus acceleration of upper block, that is 2.5 minus 1, that is 1.5 meter per second square. Let us take this is Planck is of 15 meter. Right. Now what will happen, this will be moving with more acceleration, this will be moving with less acceleration, then after some time this will fall behind it. Now what is that time after which this upper block will fall? So to decide that, I can take L is equal to half into relative acceleration is to t square. I can say it is 2L by AR root under, right? Now since L is 15 meters, I have 2 into 15 and AR is 1.5, I get 15 into 10. So this gets cancelled, this is root 20, I can say it is 2 root 5 second. Is it? Is it clear? I can find out in that situation. Now let us take some fourth example. Now if I change with same situation, if I add some more things here with pulley system, and let us see how to find out in that situation what will be. Now in fourth question is, let us connect this one with a pulley. Let us take a pulley is there and a mass m0 is hang here. M0 is hang here. Now the same situation, the M is 2 kg, M is 4 kg, right? Mu s is 0.1, G is 10 meter per second square. Now question is, what should be M0 so that M and M moves together. Now to move together, that common acceleration A0 is nothing but that is mu s into G, 0.1 into 10, that is 1 meter per second square. This is the common acceleration at which this will move. Right, and this force F is also known to us, that F I can write is equal to M plus M mu s into G, I can say 0.1 into 10, 6 is 6 Newton, is it? So I can say here also 6 Newton force is acting. Now this will be accelerated with A0 in downward direction. So when you draw the free body diagram of M0, I can write M0G minus 6 is equal to M0 into A0. A0 is nothing but 1, so M0 only, M0G minus 6. I can say M0 G minus 1 is equal to 6, or M0 is nothing but 6 by 9 into 0.67 kg. Is it? Is it clear? This way I can find out the maximum value of mass, that is 6.7 Newton of the force is acting here. I can say acceleration of this block will be in downward direction. So maximum mass will be this 0.67 kg. Now if this mass, suppose I say this attached mass, if I say M0 is 1 kg, then obviously it is more than 0.67 kg. In that situation, what will happen? The lower block will have more acceleration, upper block will have this much of acceleration. So there will be relative acceleration. There will be relative acceleration that will be equal to m minus n. Is it? So this is the one situation. Now we'll see another situation also when we apply force on upper block and the surface is smooth and there is friction between the upper block and the lower block. If you feel this topic, this numerical is beneficial for you, so please do not forget to like and subscribe my channel, that is Physics Funda by R.S. Trivedi. Thank you.